And welcome to the Daily Space Weather Smash Show, coming at you here from the Smash News Network. Least busted name in news. We've got a very high likelihood of large solar flares. We've got coronal holes. We've got an incoming coronal hole high-speed stream. We've got filaments and lots more to cover on today's most detailed imagery of the sun and comprehensive space weather you'll find anywhere in the world. This is a composite view from SDO. It's showing ionized helium plus ionized iron. Coronal holes here about to provide some high-speed solar wind for Earth. Huge filament here in the east, just rising. It's the James Comer filament. Shout out to Julie for naming that one. If you want to name filaments, join us on Twitter and accept the challenge. Let's take a brief look at sunspots and magnetic fields here before we move on. That's yesterday plus today. And we do have at least one new sunspot rose just over here. So at least one new named sunspot group. Also, we've got some growth here from this southern sunspot group down here. And let me just reiterate, the likelihood of solar flares from this area is nearly 100%. So don't be surprised to see an X-class flare, huge CMEs, and lots more exciting stuff in the realm of space weather coming from that region as those parallel equator-hugging giant sunspots move into a setting mode. There is our SDO colorized magnetogram for yesterday plus today. Let's take a look at the filament fest that's going on here. Here is the northwestern limb. And we've got huge filaments up there, including the Dick Van Dyke. Down here in the southwestern limb, this one here was named yesterday. Check out the Twitter feed if you want to see what it was named. Long, snaky filament there right in the Earth-facing portion of the solar disk. Here's the southeastern limb. Things pretty quiet down there. And activity continues to rise over the northeastern limb. I would still say the western solar equator is the most likely place to see major solar flares. And let's take a moment to look at croissant Earth. I'm interested in what's erupting in addition to solar activity. Let's see what volcanoes are currently at it. Shivaluch is producing a 14,000-foot ash plume over Kamchatka as it explodes. It is a flight level 140. Abiko also erupting. 9,000-foot ash plume over Paramushir Island. And Krakatoa now intermittently exploding. No indication of a flight level there, although dense gray ash plumes rose 300 to 500 meters above the crater. Please do not pole vault the volcanic island caldera. It seems like it would be unhealthful. Semeru on East Java also erupting, flight level 140, 14,000-foot ash plume, 22,000-foot ash plume over Popocatépetl in central Mexico. Fuego in Guatemala exploding, flight level 160, flight level 200 over Colombia from Nevado de Ruiz, flight level 190 over Sangay as Sangay explodes, in the country of Ecuador. It's a 19,000-foot plume of volcanic ash. Revenador mildly exploding. Don't pole vault that caldera either if you're going on a volcanic vacation. Leave your vault pole at home. And Revenador is producing a 16,000-foot plume of volcanic ash, flight level 160. Cotopaxi exploding, flight level 240 over Ecuador from Cotopaxi. Sabancaya in Peru, flight level 250, as it intermittently puffs. And volcanic ash emissions from Villarrica, no indication of the size of those plumes. Let's check earthquakes. And before we do that, take a moment to press like and subscribe if you enjoy the content. If you enjoy the most detailed imagery of the sun and comprehensive space weather you'll find anywhere in the world, press like, subscribe, share, comment, etc. Check out our playlists and help us out with additional views. If you haven't seen Terms Defined or SmashOmash.org Presents the Sun, check it out. Lots of playlists there with things besides space weather and meteorology. And let's take a look at seismicity. There's the past 90 days. Things have been calm here for the past 24 hours. No major quakes. A few in the 5 magnitude range. Let's scroll up the list. So there was a 5.0 at Papua New Guinea. That one came in at 2013 yesterday evening. That's universal time. One of the largest quakes. It looks like it might be the only quake above a 5 magnitude range. Nope, we've got some south of the islands of Japan here, a 5.2 down there near the Volcano Islands. Also, South Sandwich Islands region saw a 5.1. And we just had a 5.1 come in here in the southern Mediterranean there near Malta. Anyway, that's what's going on in terms of earthquakes. And let's get back to space. Here's one of our new favorite composites. It's great at showing filaments, coronal holes. The lower corona, that's the 171 angstroms portion. And the 335 angstroms provides a lot of contrast and depth. Also great filamentary contrast over here, like on the James Comer filament. And here is just ionized helium by itself, 304 angstroms. And keep watching this area right here, because that is a huge magnetic bridge of plasma that is stretching across the solar equator. And that's not something you see every day. And as that sets, that is very, very likely to produce large flares. Also, we see evolution of this sunspot down here, which certainly changes the region's ability to suspend those plasma loops. So exciting stuff going on there in the Western Hemisphere. The radio flux has now finally dropped below 200 solar flux units. And there is the one-year graph to put it in context. Spent quite a while there, over 200 solar flux units. So yeah, a huge change there in solar activity. We just saw a massive peak. The radio flux made it all the way up to 234 solar flux units. And that red line there represents the sunspot number. The black line represents the radio flux. Space Weather Enthusiast dashboard not forecasting any geomagnetic unrest or geomagnetic storms. We are expecting to see a coronal hole high-speed wind stream show up here late in the day on the 25th. Expect to see a density spike late in the day on the 25th, followed by a velocity spike on the 26th. That's a coronal hole high-speed wind stream that is on the way. We've got a trans-equatorial coronal hole. We'll talk about it here in a moment. First, let's talk about Earth's geomagnetism. KP index is currently at 0.67. KP 0.67 is the current state of affairs. And here's Earth's magnetic moment from space. So this is the past 4 hours out to about 12 Earth diameters of magnetohydrodynamic pressure. It's our Geospace Magnetosphere movie. And we show it daily on the channel. We do have an elevated solar wind speed here. We'll get to it in a moment. First, Earth's magnetic moment from the ground. And we're seeing some issues here with the map that we usually show. So we're going to show the polar view instead. That'll still show you the most likely areas to see the aurorae, pipeline, railway induction, power line induction, etc. That's Earth's magnetic moment from the ground in nanotesla magnetic flux density. Geospace delta B is changes to Earth's B field. So next, move to the real-time solar wind. And again, we do see an elevated solar wind speed here, currently a little over 500 kilometers per second. 503 kilometers per second is the solar wind speed at the moment, as measured at Lagrangian point 1 by ACE and Discover. And you've got the density there at 10 protons per cubic centimeter. We also did recently see a shift here in the BZ, that top pane there, the red line. That's the vertical component of the magnetic field. And of course, if that stays that solid negative BZ signal, we may see us approaching geomagnetic unrest conditions even without any changes to the solar wind density and speed. Next, we'll take a look at magnetic data. We've been seeing some higher readings here from the GOES 16 and GOES 18 at their geosynchronous orbits. And let's take a look at the heliospheric current sheet next. I think this is the best way to forecast solar activity that there is. And what I'm going to say based on this information is that the recently rising sunspot in the northeast is going to be a major sunspot because I can see the South Pole current sheet accelerating here. So if you look at the last few frames here, you'll see the South Pole current sheet accelerating towards stereo A. That's located right there at Lagrangian 0.5. And that's an indication that that may be a strong sunspot. So that's my forecast. This is the top view ecliptic plane field plot, which is the best, in my opinion, way to forecast rising solar activity, even better than looking at the active regions on the stereo A imagers. Anyway, here is our line of sight field plot. Solar B field depicted here in blue, north and south solar polar fields depicted in green and red respectively. Next, coronal holes. We've got two very well-defined coronal holes here at the moment. We've got some South Pole-oriented coronal holes here rotating in the east. So here's the view from SDO. And of course, you've got this trans-equatorial coronal hole right here. We think we should start naming these after land masses, as they have the appropriate type of shapes to be named after land masses. Let us know what you think in the comments. So I think we should name filaments after living people and coronal holes after land masses. Let us know what you think. And if you know what that's shaped like, drop us a line on Twitter, take a screenshot. And by the way, please visit our links. Help support the channel with some merch. We're going to get to Sunspots here next. If you click the red bubble link below the video in the description, you will find our merch shop in order of best selling. Of course, we want you to have souvenirs for some of the things that have been going on in the past 3 years. You may have noticed a little bit of incompetence, propaganda, fraud, nonsense, etc. Today's featured product is a re-release. It's Smasher Price, My First Pandemic. It's one of our first merch items that we created since the world was masking and ridiculously arguing about the efficacy of these type of masks in general. Of course, throughout history, have they been effective at the Black Plague or at preventing the Justinian Plague? What about the Spanish flu? What about the H1N1 and all the other Asian flu outbreaks throughout the 2000s? How did they work back then? Did they work in 2020? What about 2021? What about 2022? Are people still wearing them in 2023? Let us know in the comments. Get yourself a souvenir, and congratulations on surviving a global scamdemic so far. We demand accountability for the past 3 years. It always comes in one way or the other. So, yeah, congratulations once again. If you want to support the channel via subscription memberships, we are still on Patreon. Smash Staff does post the content to Patreon, so if you want to support us that way, feel free, patreon.com/smashomash. But the best way to support us is via our own subscription services site. We built our own at smashomash.com/SmashTeam. We needed additional capabilities, so we got them by building our own website. Shout out to Smash Staff. Give her a raise by becoming a member of the Smash Team. And if you want to know the mechanism underlying the solar sunspot cycles, become a gold Smash Team member and help us write the paper that we are currently authoring, explaining the mechanism that underlies the solar sunspot cycles and solar polar field reversals. It's kind of serious. And when the paper passes peer review, it'll be, the most important science paper in hundreds of years. Gold members have already been informed what the mechanism is. Smashomash.com/SmashTeams, and we're on to Sunspots. So there we go. 3200's gotten named, and we'll have 3201 having just risen behind it. I think it's going to be a major sunspot, and I think we've got major flares coming around the western equator. So let's take a look at sunspots here. As we have been seeing some activity increasing, we've been seeing the X-ray flux increasing as those two massive sunspot regions approach a setting mode in the west. No surprises there to our regular viewers, and perhaps another active region rising down here as we do see another bright spot there, noted by the 171 angstroms wavelength. So here we've subtracted 171 just to include the SDO continuum, and let's zoom in as that is insufficient information. I would note especially the growth of this sunspot. So it's looked like it was degrading, and now it's gone back into growing a bit for the past 24 hours. A little bit of growth showing up there. And again, a lot of plasma suspended across the solar equator there, a very turbulent zone. You know, keep in mind, folks, the solar equator is moving at a very, very fast speed. If you think Mercury's fast, well, the sun rotates even faster than Mercury's orbit. So, I mean, the solar equator is moving at a very, very high speed. I don't know exactly what it is, but if you feel like looking it up and dropping us a comment, let us know in the comments. I try not to memorize statistics like that as it takes up space in my brain, which I need for other things. So let's move on here to energetic particles. No spikes in the proton flux in the past 24 hours. Those are relativistic particles that are picked up by the GOES 16. And as far as the photons being picked up by the GOES 16 and GOES 18, again, the flaring profile has come up quite a bit in the past 24 hours. We saw it diminish, and now it's coming back up again exactly as forecasted as those sunspots reach the western limb. So here is the one of two of the best views to look at flares with. 131 angstroms from SDO, and thanks for leaving a comment, Mike. We'll also show 94 angstroms. And how about if we zoom in and combine? So exactly as forecasted, you can see flaring increasing on those active regions, those two massive sunspot groups in the west. And let's take a step back before we go to coronagraphs and filaments and CMEs and so on, and take a look at the sky overhead. Now, of course, it's light over Lehigh Valley, Pennsylvania, and we've just set this up to not show daylight, because we want to show you what's going on in terms of stars. So if you are up before dawn, you may see Mercury rising ahead of the sun. There is the view of the horizon over Lehigh Valley, Pennsylvania. There's where the ecliptic meets the horizon. Mercury up there in the sky, and let's do a solar system forecast. We hope you enjoyed your new moon. All our reverse werewolves out there, we hope you slept well at night, didn't cannibalize humans, and we're happy, productive, diurnal members of society. Here is your 1-week solar system forecast. We will have a gibbous waxing moon by then, as Earth moves around to the lonely side of the sun, the side devoid of gas giants, as Venus plays catch-up. So next we'll look at coronagraphs. Here are yesterday's coronagraph images from George Mason University. There were some CMEs. Are they earthly directed? We'll let you know here in a moment. With some additional analysis, first, today's coronagraphs. There are 41 more images. So some CMEs happening there, and the likelihood of those directed toward Earth is kind of low, but let's take a look anyway, because if you don't look, you might not know. You know, simply observing coronal mass ejections is one of the reasons why we discovered that certain other space weather channels are utter hack frauds. Because back in May of 2019, somebody claimed there wasn't a CME when there indeed was a CME, and we didn't like that. It led to some unfortunate statements made by the said hack fraud parties on Facebook. Anyway, let's pause this and bring this back. We don't see any Earth-directed CMEs here. We've got pretty good data there from stereo A. And if there was an Earth-directed CME, it would have to be on this line, approximately. From stereo A's perspective, we ain't got nothing like that. We just have a little bit of fireworks happening there, not fireworks directed toward Earth. So there's the past 24 hours. We'll zoom out. And then we'll zoom out even further. that's the last 24 hours with our Coronagraphs and SDO 304 angstroms. Which brings us to filaments. So we've got some filaments here. Yeah. Got some instability happening up here. Just behind the Dick Van Dyke filament. I believe that one's not named, I don't think. This one down here is named. Again, join us on Twitter to name filaments. If you want to name filaments after living people, you have to either leave a comment on a Twitter post or leave a tweet and tag us in the tweet. Then we will share it. And that'll be the naming convention. You can't name the filaments on YouTube comments or any place besides on Twitter. So that's what's going on with that. So make sure you follow us over there if you want to name filaments. Thanks to everybody who has. As the pathetic, putrid, disgusting, and foul shadow bans continue on all major tech sites. Next, look at the last few hours from the Agose 16 SUVI to see a CME erupting as we stream the video. So this is, it could actually be the Dick Van Dyke filament, I'm not sure, but looks like some CME activity happening there. Doesn't look like it's particularly earthly directed either here. It's way up to the northwest. And let's take a look at the last 24 hours here from SDO. Two of the classic wavelengths there, 304 plus 171 angstroms. That brings us to our bonus feature segment, where we'll start out by looking at satellite charging hazards, which are not present at the moment. Continuing on to our electron flux as measured using radiography from their geosynchronous orbits by the GOES 16 and GOES 18 satellites. We've seen the electron flux come up here off the floor. We can expect to see this crater once again when the coronal hole high-speed stream shows up in earnest. You can see a little bit lower levels here than forecasted by NOAA yesterday. And you can expect significantly lower levels here, right about here, when the coronal hole high-speed stream arrives. So that will be on the 26th. There is the relativistic electron graph. And let's take a look at the F flare of the ionosphere, the vibrational frequency of the bridge between Earth and space. Major anomalies continue, especially around South America. So there is the raw vibrational frequency. We show it daily on the channel, by the way, so if you want to see a previous day going back years, go watch our old videos. We've only missed a few days in pushing 6 years of daily space weather videos. Let's look at the anomalygram next. So here's the anomalygram. That's anomaly in megahertz from a 30-day median. We've documented over and over again how the South Atlantic anomaly is now in the South Pacific. The South African anomaly is now near where the African continent meets the equator on the west coast. And we're seeing huge swings here of high to low frequency anomaly in various spots. So the ionosphere here quite unsettled. And we'll show the latest images. There's the latest image ionogram. Huge anomalies happening there. And there's the latest anomalygram. So you can see those massive high-frequency anomalies and low-frequency anomalies. Rapid swings happening right now. The ionosphere is ringing. We'll also show the total electron content. But before we do that, let's talk about the Outer Space Treaty. I don't know if you're aware of it, but there are reasons why we shouldn't be detonating nuclear weapons in space. And of course, the international treaties are not necessarily honored by everybody. They're pretty hard to enforce. It's pretty hard to enforce laws about space. But part of the reason why there are nuclear test ban part of the reason why there are nuclear test ban treaties in place in the first place is because of detonating nuclear weapons in space. It's very sketchy detonating nuclear weapons in space, as it creates electron bridges that just hang out for extended periods of time, like 7 to 10 days. You'll have just an electron bridge up there, and we're not really sure what that would do. So we've sort of just collectively decided as a species to stop detonating nuclear weapons in space. It's extremely creepy and weird, creating an artificial electron bridge up in space. So anyway, this space law treaty happened all the way back in 1967, and it was the U.S., the U.K., and the Soviet Union that created that outer space treaty. If you want to read about that, that's a wiki article. And let's take a look at the total electron content forecast, as it's been extremely anomalous. That is the free electrons between your GPS satellite at about 12,500 miles and your handset. So huge anomalies continuing here, and basically no end in sight until we see the electron flux reach higher levels here for that to get a little more organized. At the moment, very disorganized total electron content. Also anomalies there over southern South America, the Caribbean, and also bands of oddly low electron content around the 40 degrees north latitude, as well as 50 degrees south latitude. Right in here, these odd low electron content regions, very strange. Huge GPS errors all around the world. Perhaps turn on your Wi-Fi location accuracy if you are navigating. If there are Wi-Fi hotspots around, that should help. Your GPS could be off by thousands of miles if those red areas are overhead when you're navigating. We'll close out the space weather segment with the latest intensitygram and latest colorized magnetogram. So do we see a new sunspot down here? Well, certainly not. That's a plage. It looks magnetically organized, but it's just a plage, not a sunspot. Up here, we certainly do have a new sunspot. And there you can see that new sunspot rising. I've got high hopes for this sunspot group and this sunspot group. Those are, well, this one's alpha class at the moment, but this one is beta gamma class. So anyway, there's the rock back. This sunspot down here, that did feature perhaps the largest single umbra that we've seen so far during solar cycle 25. So also this region here has just recently grown a little bit. So that's always interesting. Again, the most likely place to see major solar flares is from this area. So that is where the space weather portion of the video should end, and the meteorology segment should begin. So I would just remind you, thanks for leaving a comment, Tinman1057 as well. I should remind you to please visit our website. Our homepage is smashomash.com. That's the official homepage of the Smash News Network, least busted name in news. So help us out with clicks. If you're in the market for some Hemp Lucid products, or if you want to hit us up on social media, you can also find links to the Redbubble shop there on the homepage at smashomash.com. We built our own because we found it a little unacceptable, certain things that were going on social media sites, so we had to get our own servers on our own .com and .org as well. So anyway, so check it out. Here's where we're starting out meteorology. And what are we looking at here? Is that an alien spaceship causing a whirlpool off the coast of Canada? Well, no. That is an eddy, interestingly enough. There's a whirlpool off the coast of Canada. Something I wouldn't have noticed, but I was looking at currents. There you can see a strong current. It's about a 6 mile per hour eddy there. A giant whirlpool off the coast of Canada, in between Canada and Greenland. And the reason I was there is because I was looking at the Gulf Stream. Why was I looking at the Gulf Stream? Well, because the Gulf Stream, folks, is the canary in the coal mine, right? When the Gulf Stream does not make it up here in between Ireland and Iceland, it causes Europe to freeze. According to the geologic record, the albedo effect then goes out of control, and we get the standard issue snowball Earth that we've seen over the past very long period of time on the planet. So the warm periods like you're in now are the uncommon portion of the past few million years of history. What's a lot more common is snowball Earth scenarios, which are not particularly good for the human population, by the way. It's very hard to grow crops when your soil is under a mile of ice, for example. But in any case, the reason I'm showing it is because we don't see that breaking down. The Gulf Stream is continuing to warm Europe, and them's the facts. And we're going to show some more facts here in a minute. We're going to talk about, snow. We're going to talk about snow. So, of course, there's a lot of snow jobbers on YouTube that like to cherry pick data and not provide the truth, the whole truth, and nothing but the truth to their viewers. That is a characteristic you will not find on our channel. So let's take a brief look at the winds around the planet, and then we're going to talk snow for a brief moment. There are the winds of the surface region of the eastern planet. Here are the jet streams. Powerful jet stream here over the western Pacific. Here are the jet streams of the western world. Huge bends in the North Atlantic there. Some warm air being driven up into places like Scotland. Next, surface winds of the western world depicted here. Surface winds of the central world. As so, and there are the jet streams. And let's talk snow. So, the 2022 to 2023 winter season has not featured as much snow as the previous 6. So the last 6 winters featured record snow mass balances in the northern hemisphere. So this particular stat over here on the top left, that is the snow mass balance. And that's very important because that's the 3-dimensional estimation of snow, not including mountains. And we're seeing normal levels here as opposed to well over 1 standard deviation above normal levels that we've seen for the last 6 winters. So as far as this winter goes, it's looking a lot more normal. Snow water equivalent is still very high, well over 1 standard deviation above normal, and snow extent is actually over 1 standard deviation below normal. So that's the current state of affairs. It looks like the northern hemisphere at least may be coming out of its, well, put it this way, I don't think it's going to be a 7th consecutive winter of record snow mass in the northern hemisphere, which is probably a good thing for all of the alarmists out there who are trying to convince you that you're in a grand solar minimum, which does not appear to be backed up by the solar data. And fortunately, this is not looking as crazy as it was. Now, keep in mind that blue shaded area is the average for the 1982 to 2012 period of time, and that's the plus or minus 1 standard deviation for snow mass balance. And so now maybe that should be adjusted because of the last 6 winters, since they were 6 record northern hemisphere snow mass balance winters. But that's the current state of affairs, things looking a lot more normal than the last 6 years. Next, we're going to look at clouds and fog over the Americas. And another quick reminder here, since most of our viewers are into space weather, were you aware that the solar minimum between solar cycle 23 and solar cycle 24 was more minimal than the one between solar cycle 24 and solar cycle 25? Indeed, it was. The Earth's thermosphere was colder. Cosmic ray flux was higher between solar cycle 23 and solar cycle 24, around 2009, 2010. Solar activity was lower. In other words, there were less sunspots and a lower radio flux. So the most recent solar minimum, which was around November of 2019, was not as minimal as the one back around 2009. Anyway, that's clouds and fog over the Americas. Here is your weather.gov map. If your county's lit, click your county, or if you're seafaring, click your location to get your weather alerts. Hopefully you don't need weather alerts from weather.gov if you're seafaring, but in any case, if you are, and drop us a comment. There's your map. We scrolled down to show you the key, and let's move on to some forecasts. So we've got some strong weather here. A strong low is forming in East Texas at the moment. We've got some snow falling in various places here. That's the 72-hour GFS forecast for pressure and precipitation. Here is your 72-hour GFS forecast for total accumulated precipitation. Some heavy rains there expected for central Louisiana in the coming days. And since a lot of that precipitation will be in the form of snow, there is your GFS 72-hour accumulated snow depth change in inches. So it looks like all of Pennsylvania here is going to be coated. Let's take a look at the Euro forecast as well. So that was the GFS forecast for snow over the next 3 days. There's the Euro forecast for snow over the next 3 days, and we'll show you the difference between the Euro and GFS models. That's the Euro model. That's the GFS model. Big difference there for the central part of the country there. GFS model predicting much heavier snow for places like Arkansas, Missouri, and Oklahoma than the Euro model. Euro, GFS, and let's move on to our lightning mapper. So Florida saw some lightning in the past about 10 hours. Let's see if we have any terrestrial strikes at the moment by checking out lightningmaps.org. No terrestrial strikes in the U.S. here. There's a strong system there in the north-central Atlantic. Also an errant strike in the central Pacific. Anyway, let's close this mother out with U.S. Doppler radar. There's some real-time data for you. We'll focus on the lower 48 for the remainder of the video now that we've showed all 50 states of AUSA, the allegedly United States of America. That's what's going on. Here is clouds and fog. That's a 3.9 nanometer radiation map projected onto the fake spherical Adobe Photoshop NASA globe. Everybody knows that the Earth is croissant-shaped. Perhaps that's why we have so few viewers on YouTube and so few followers on Twitter, because they don't want the information to get out about the fact that Earth is shaped like the French pastry. Welcome to Croissant Earth. And here is our recap, because it's time to close this thing out. Doppler radar for the lower 48, as things are clearing up in southern Florida slowly throughout the day. There is clouds and fog. That's infrared radiation at the 3.9 nanometer radiation band. And there is water vapor. It's looking like clear skies over San Diego here at the moment. And we hope you enjoyed the content. Thanks for tuning into the Smash News Network, least busted name in news. I've been your host, Dan, a.k.a. Smash-O-Mash, signing off. And may that solar wind be at your back. Opinions expressed in this video are not necessarily the opinions of Smash News Network, least busted name in news.